And before that, I did a little bit of development, application development, Q&A as well. But yeah, 16 year is in DevOps, right? Today, we are going to talk about Docker. So we are going to have a brief introduction. Come on. Yeah. So we are going to have a brief introduction about Docker. We are going to understand, why, what, and where about Docker. So why do we use it? What do we achieve with it, and where do we use it? And we are going to have a small, architecture discussion, some components we are going to talk about, what are basic Docker components, and then we'll have a demo on Docker, right? So it's a very, very basic discussion, and think of it as the first session on Docker. What is Docker and how does it work, right? So I'm going to talk for about like 45 minutes, and I'll have the rest 10 minutes for Q&A. All the questions, if you have questions for me, please use the Q&A window. Do not use the chat window to ask me any questions. Please use the Q&A window to ask me questions, and I will answer them, right? But after the session, after when I'm done explaining, then I will answer the questions. Okay, so let's start. First, let's understand what is Docker and why do we use it, right? So let's say you have okay. So let's say you have an application, right? You have an application and you have application code, right? You have application code, and what generally you do with the code? You take the code and then you compile it, right? And after compilation, you generate a binary out of it, right? And then you deliver the binary to a customer. Right? So you have code, you compile it, which you generate the binary, which gives you the binary. Right? And then you hand over the binary to your customer, and the customer may do whatever they want to do with the binary, right? They may deploy it somewhere, or they may share it with their IT team or whatever. Right? So this is how generally software development happens. There could be some more steps in between code and binary and delivery. For example, between code and binary, you can do compilation and you can do static code analysis, or syntax checking, code reviews, and things like that. Between binary and customer, before delivering to the customer, you can do your Q&A, you can do your build checks, you can do your security check tests, whatever. But this is the overall view, right? And the customer, when they take the binary, let's say it's a web application, right? A simple web application which displays customer's homepage, right? Let's say the customer is Google, then the homepage of Google. That is developed in this code, and the binary is generated, and then the customer uses it. What do they do with the binary? They take a infrastructure, right? For example, they would work on a server, and on the server, they are going to prepare the server for running this binary. So they will install utilities. Let's say this, let's be a bit specific. Let's say this is Java code, right? So this code is based on Java, and the compilation happens using Java C, right? And the binary is, let's say it is a jar file or a war file, right? So the customer, what they do on the server, right? They prepare the server. So they install utilities, right? For example, install JRE or maybe JDK to run Java-based applications, right? They may also install a web container, right? For example, Tomcat, where they can run the war files, right? Before that, they may have to set some environment variables, set env variables, right? So they prepare the server so that they can run this application, right? And then after preparation, the actual deployment happens where they deploy the war file. Okay, are you guys with me? Can you guys hear me? Some people have mentioned that they can't hear me. Okay, am I audible? I'm audible, right? All right, cool. Okay, so this is the general practice, right? Now, please don't use Q&A for answering my question, like for this audio question. Use it for your questions. Okay, now the thing is, let's say this is version 1 of the Java code, version 1.0. And then I come up, the software team, the development team comes up with a new version of Java code, right? New version of Java code. And let's say this version is version 2.0. Okay, version 2.0. And then again, this is going to be compiled and a war binary will be created. Right? A war binary will be created after compiling it. And let's say to run the Java 1.0 based application, you require JRE or JDK version uh, 8, right? Java version 8. And now with this new Java code and the binary, and it is being delivered to the customer now, but for deployment, you require Java version 9, Java version 9, or let's say 11. Here it required Java version 8, and now your source code now works with Java version 11. And you got a binary, the war file, and the war file is delivered to the customer, right? Now the customer has to deploy this one. So they want to upgrade their server. They don't want to run the 1.0 application. So they want to install 2.0. Now there is a dependency with 2.0. They cannot simply use this server because they have JDK 8 here. So they want to move away from JDK 8 and choose Java 11, right? They cannot use this. They cannot use version 8. They have to use 11. And maybe because of that, previously they were using Tomcat version 7, but now they have to use Tomcat version 9, right? So there could be dependency changes. So because they want to run the application or latest version of the application, they have to again prepare the server to get rid of the older versions, get new versions in there, and then run the application, right? It's a complicated way of managing the application. Similarly, there could be other customers, different kinds of customers. They could be also using the same binary, and they may not even know how to manage this server, right? They have a very small IT team, and they don't know how to set up environment variable. They don't know how to set up Java. or Tomcat. So, setting up this environment and preparing this environment to run your application is a bit of a challenge, right? So, how do we solve this problem? So, to solve this problem, we use what is known as containerization. Okay, so this is our problem statement, right? And let's have a solution. Now, the solution is we don't deliver the war file to the customer, right? What do we do is we have the Java code and then we compile it and we get the war file. But then what we do is in the war file, we add, or along with the war file, we add the dependencies. And the dependencies are for example, the environment variables and things like that. I don't know why my system is behaving like that. Okay, so so for this war file, there is a dependency that it runs uh, only with certain environment variables and certain version of Java and JRE. So this is the dependency. What we do is we create a bundle, right? So we create a bundle and let's change the color a bit. Yeah. So let's call it as Docker image. Okay. And this bundle will have these dependencies, right? And along with the dependencies, it will have the war file. So we combine the war file along with the dependencies and we deliver that to the customer, right? That's called a Docker image. I'm going to get back here on to explain to you what is a Docker image in a bit, but think of it as a combination of your application plus your dependencies. Okay. Similarly, when the new version is delivered to the customer, we don't deliver just the war file, right? We deliver along with dependencies. So this here the dependencies 11 and Tomcat, let's say 10 version. Right? So Docker image, this is Docker image version 1.0, and this becomes Docker image version 2.0, and we deliver that. Now, what is the benefit? What changed? So what changed is the application which used to come standalone to the customer. Here, the war binary file used to go to the customer, just a standalone binary file. Now it goes along with the dependency. So the customer does not get the application only, the customer gets all the dependencies. Okay. So now the customer has everything that is required to run the application. Now, what do they do? How do they run the application? The first thing is they install Docker on a server, right? Wherever they want to run. And then they run container paste or run a Docker application. Okay, what does that mean? That means the customer now has Docker installed on the server where they want to run the application, and they just take this bundle of application plus dependency called Docker image, and then they run the application from this Docker image. What's the benefit? The benefit is the customer just has to manage Docker here, and they don't have to worry about any dependencies the application may have, any configurations that the application may require. They just download the image, Docker image, and run the application based on it on the server. Okay, and if they want to upgrade, let's say they were running Docker image version 1.0 application, uh, what they can do is they can just, if they want to upgrade, they can just stop running this version and start running this version, right? And as soon as that is done, the application comes up. They don't have to manage all these dependencies manually. Make sense? Please don't use Q&A for responding to my question. Manish, your question is fine on Q&A. So, yeah. All right. So if this makes sense, then let's talk about, so this is called containerization. Yeah, putting your application along with, or bundling your application along with dependencies is called containerization. Okay. All right. So now let's talk about, just give me a second. Yeah. I will just open an architecture diagram. Yeah, maybe this one will work. Okay. So this is an architecture diagram of Docker. So what it does, what are we talking about here? How does this work? How does image and its life cycle works? Yeah, let's take a look at that. So we have something called as a, a registry. Let's start with registry. Okay. A registry is, let me, all right. So the registry is a place where whenever somebody has a Docker image to share, right? Somebody created an application and they want to share the application along with their dependencies to other people, they can save or they can upload the image to a registry and other users can use it, right? So this Docker registry is a service to share Docker images. Yeah. For example, GitHub is to share your Git code. YouTube is to share your videos. Similarly, if Google Drive is to share your files, then similarly, Docker Hub is to share your Docker images. Okay. So registry is the proper term. Anybody can set up a registry. Docker also provides a registry called Docker also provides a registry called Docker Hub. So you can use Docker Hub to upload your images, or you can set up your own registries, or you can use somebody else's registry. For example, Google Cloud provides their own registry, AWS provides their own registry. So you can upload your images there. Right? For example, these are example of images which are available on Docker registry like Ubuntu or Nginx or things like that. Okay. Now, how does the image go to a registry? So an image is first created and then uploaded to registry. So we to manage any image or anything for Docker, we need to use a machine called Docker host. Okay. Docker host is nothing but a system, a computer where there is Docker installed, right? A Docker service is installed, a Docker tool is installed, right? So that is what is called a Docker host. Okay. So if I have a machine and um, I run Docker on it, that is called as a Docker host. Okay. So what do they do is a developer who is creating Docker image is going to use some command line tools like Docker Hub, for example, sorry, Docker build. And this Docker build command is going to talk to the installed Docker service, and it can be used to create images, right? So using Docker build on a Docker machine, you can create Docker images and then publish the Docker images to the registry, right? Similarly, on a Docker machine or a Docker host, a developer can download images from the registry by running a command, for example, Docker pull. With the Docker pull command, the developers or anyone can download a Docker image from registry to a local machine, right? And once an image is downloaded on the local machine, then um, you can run the application by using the run command. I'm going to show you a demonstration of all these commands. If it is too much to remember, it's fine, right? So this is what happens in Docker, right? And here in this example, right? So when we create Docker Hub images, we don't directly give them to the customer, we upload them to Docker registry, right? It could be Docker Hub or any other registry. So the delivery goes to registry, right? And the customer then downloads the Docker images on this machine. So does a Docker pull, which downloads the Docker image and then run the Docker application, right? And here it becomes Docker push, right? And here it becomes, just give me a sec, Docker build, right? So with the Docker build command on a Docker machine, you can create Docker images. With the Docker push commands on a machine, you can push the image to a registry. And with the Docker pull command, you can pull the image from registry and run the application container there. Okay. So these are the basic concepts in Docker. Let me show you a small demonstration for this. So yeah, we pulled that. Uh, 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 just give me a second. We have the command. Yes. All right. So I already have a machine with me, which I'm going to connect to. Okay. So I've set up a system. Hopefully it is up. Yes, it is up. All right. So this is a machine which I have created just for this demonstration. It's a brand new machine. It's an Ubuntu based machine. Let me become root first, and let me quickly install Docker on it. So this is a Ubuntu based machine. Let's convert it into a Docker host. A Docker host is a machine where Docker is installed, right? We need Docker host to work anything related to Docker. So we need to install Docker daemon. Okay, let's do that. So we are connected to the machine. I'm going to say apt install docker.io. This is going to install Docker daemon or Docker service on my machine. Docker is now installed. Okay. Now, let's say, um, let's first explore the Docker registry. So I'm going to open Docker Hub. So this is Docker Hub. And if I explore Docker Hub, you can see here that there are already a lot of Docker images which are published, which can be used by anyone, right? So there is Alpine, there is Nginx and all. Let's see an example of Jenkins. I'm not sure if you have heard about Jenkins. Jenkins is a CI application. And I want to show you the capability of Docker. So we'll start with Jenkins to just demonstrate how it solves a big problem. So let's say I want to install Jenkins on Ubuntu, right? If I want to install Jenkins on a simple Ubuntu machine, I have to follow all these process. I have to set up a repository, set up a key, and then do an apt update, and then install Jenkins. I may also have to set some configurations, some certificates, and things like that. So I will have to install Jenkins, I will have to do all these things. But since I already have a Docker machine, a Docker host, and there is a Jenkins container available for us, or Jenkins Docker image. This is a Jenkins Docker image available for us. I can use this and run application, right? So if we go back to our presentation here, the Jenkins team would have written the Java code for Jenkins, right? Let's be more specific. So the Jenkins team must have written the Java code for Jenkins, right? And then they would have compiled it and they would have created a var, and then they added the dependencies along with the var, did a Docker build and created a Docker image, right? So you can see here, there is this Jenkins Docker image and it is available on Docker Hub. That means it has the application and the dependencies already. So instead of installing Jenkins like this, I can use Docker to just download this image and run application from it, right? So I copy this command, which is a Docker pull command, and I will download the Docker image here on this Docker machine. Okay, so I can run the command. I said Docker pull Jenkins/Jenkins. So Docker is Docker, pull is to download image from the registry, and this is the name of the image. All right, press enter, and you see it downloads something. Just wait for it to finish. Done, right? So if I do Docker images, you see this image is downloaded. It's of 474 MB size, right? So now let's run the image base out of it. I will say Docker run dash d p Jenkins/Jenkins. So what I say is I want to run the application which is in this image, which is Jenkins/Jenkins. Okay, just run the application. And that is all that I'm going to do. Okay. Don't worry about these options and things like that. With time, we will learn about these. But if I press enter, I get some ID, right? Now, what happens here is when I run an application based on Jenkins/Jenkins, Docker creates a new process to run this application. Yeah. So what I did was I did Docker pull to download images from the registry. And then I do a Docker run, and that runs an application based on that image. In our case, it is Jenkins. And such execution of application is called a container. Okay, it is called a container. So if I run a command called docker ps, it is going to show me all the running containers. Okay, it's a bit zoomed in, so you cannot see the result in single line. It goes something like this, right? So docker ps, it shows me that there is a container running, which is called beautiful Northcut. It has the ID of this. This is the same ID which is here, which was generated. It is based on image Jenkins. It runs some command inside, and these are the ports where it is available. Okay, so this is how I run my application. Now, what happens now? I'm running the application. But if you see, I did not install any dependencies for Jenkins. Jenkins is written in Java. I did not install Java on this machine. I did not install any Tomcat. I did not put any configurations. I just said, run this container. And that's it. And now I can, if I browse to a port 32769 of this machine, I will be able to access Jenkins, right? So if I just say, this is our machine name, and this is my port. And you can see Jenkins. Jenkins is installed on this machine and it is up and running just by using Docker, right? So the point is, with Docker, you can use an application directly on a system along with its dependencies without worrying about its configurations, installing dependencies, maintaining a server. Your overhead becomes very less. The most of the responsibilities now lie with the development team to actually provide correct dependencies. And development team builds Docker images and tests them so that they work on Docker. And this also makes it platform agnostic. That means you can run this Docker image on RHEL, on Ubuntu, on CentOS, on Alpine, on any Linux, on Windows, on Mac. You can run these images, right? So it makes life easy for everyone. You can just create a Docker image and expect it to run on or any kind of system. And the end users, the customers, they don't need to manage any infrastructure to run this application. It just works for them, right? So that's what Docker is. Now, if I say, hey, I don't want this application anymore, I can simply say Docker stop a container and give the name of the container. And it's just going to stop it. And as soon as I do that, I will not see Jenkins anymore here. So the application stops running. Right? So this is Docker. But yeah, it has a lot of um, options, lot of configurations, lot of advanced tools as well, like Docker Compose, Docker Swarm, um, various options for running the commands, various capabilities, which is very difficult to cover in this particular session. So maybe in the future sessions, I'm going to try to cover that. Okay. And that's all I wanted to share with you. I just wanted to let you guys know what is Docker and how it works, and just introduce you to the world of Docker. And now I'm going to take some questions. So I'll go to the Q&A window and try to answer some questions. All right. So the first question is how to create Docker image. You can use Docker build command to create Docker image. Uh, but then for that, you need to write some configuration files. It is a bit of a work initially to set up what you want to build. And when you create a Docker image, you need to specify what goes inside the image. So which application goes inside, what is which dependencies go inside, what configurations go inside, right? Sindhu, the Q&A is in Zoom itself. So there is a button for Q&A, right? To run Docker version v 2.0, does the container need new version of Docker? No, same version of Docker will work fine. So we have to create Docker image for each and every version to compile. Yes, of course, you have to. And you can use CI processes. You can use Jenkins, or Docker also provides you some CI to automatically build image whenever new code is there. From where Docker will pull the dependencies. Docker image contains the dependencies, and that is added to the image when you do a Docker build. Can you explain with examples? I think I just explained it. So this Docker image will check if prerequisites applications are installed. No, Docker image will contain prerequisite binaries. About replacing a container with an updated version, how are local changes managed? For example, SSL certificate was attached later post deployment. So yeah, very good question. So if you have, let's come back to the diagram here. Yeah, so you may have extra configurations on top of the default containers. So when you run a Docker container like Docker run Jenkins, you may provide some more details to Jenkins. For example, you want to have some certificate files, you want to have some default username passwords, you want to have some default configurations. So how do you provide that? You can add your own files to the containers, which can contain the data. For example, certificate files, you can mount inside the container at a certain path. You can pass environment variables, yeah, and things like that. Just give me 1 second. All right, sorry about that. So that's how you can add more configurations if you want, customize your Docker run based on, uh, you know, extra on top configurations. Good question, thank you. Okay, I think I answered this. Any prerequisites to install Docker image? Nothing is required, you just need Docker. What is Docker CE? Docker CE means Community Edition. There is Docker Enterprise Edition as well. So in some cases, you may go with that, but generally you should install Docker CE. Did we have any demo instance for creating and deploying application? I'm not sure what is the question, but I just demonstrated on a machine which I created for myself. How would we know which image is genuine? One out of so many images. Okay, something which I would like to explain now. So on Docker Hub, always look for images which have these badges. So a green badge means it's a Docker official image, which is created by Docker. Verified publisher is a publisher who is verified and the Docker verifies their Docker images, right? Sponsored is uh, by an organization which sponsors Docker, and Docker also verifies their images. So these three kind of contents are trusted. You can see this Alpine image is a trusted content, it's a Docker official image. And if I look for Jenkins, you can see a Jenkins is a certified sponsored OSS image. But if you look at some other images, if I look for Jenkins and if I go down somewhere, you know, in 7th, 8th, 9th page, you will see many images which have none of these tags. So these are images created by someone who may or may not be malicious. So I wouldn't trust these images. I would only trust images which have these three badges, one of these three badges. How does the system know which registry to pick the image? The default is Docker Hub. But if you want to pick from other registries, then the Docker image name will have the registry reference as well. Is Docker acting as a version control as Jenkins fetching code from Docker Hub? Jenkins is not fetching code from Docker Hub. Entire Jenkins binary is fetched from Docker Hub. So no, it's not a code repository. After installing Docker Ubuntu, where is Docker registry configuration defined? It's built in. Docker by default talks to Docker Hub. Will the PPT or document be shared? Not the PPT, but the video will be recorded and shared with you. Are these images placed by default by Docker? If we want our application plus dependence to be available in registry, then we need to push these as an image. Yes, you need to build your image and push it. How to create Docker image? You can use Docker build, and we are going to talk about it later in some other session. What is RHEL? Red Hat Enterprise Linux. Can we make changes in configuration file as well using Docker, or it can help in software installation? You need to elaborate more which configuration file and what changes are you talking about? Can we run multiple Docker images? Yes, you can run multiple Docker containers. You don't run images, you run containers out of images. You can run multiple containers. What does port signify? A port, okay, this is a computer science question, not a Docker question. A port is nothing but a socket where you connect to a remote computer, right? There could be an application running or there could be a server running on that port. So it's that. I think you should read about ports and sockets. What are the limitations we will face when trying to use Docker? Like, for example, disk size, RAM usage when running the Docker. What are the best practices? Very big question. So there are no limitations as such. The limitations, so if you don't go by the default installation method and use Docker, the only thing is you are dependent now on getting a Docker image from the customer. So obviously, the war binaries or the binaries are created before Docker image. So you may have to wait a bit after official release of the software. You may need to wait a bit to get your Docker image, right? Apart from that, I don't see any challenge. It's a well accepted solution, and the entire industry uses it. So no challenge, I guess. Best practices while creating a Docker image. I think when we talk about creating Docker images, that's the time when we can talk about this as well. What is the command you had used to install? It is simple apt install docker.io. You can look for installing Docker on Ubuntu or RHEL, whatever you have, and you will find it. It's pretty straightforward. Is a meeting recorded and slides shared? Meeting will be recording will be shared with you. Can you share small POC for Docker image? I'm not sure what you mean, but if you're looking for like a small project, then you can search over internet. There are millions of them. How can we authenticate if the image is secure? So you have a command called Docker login, and with Docker login, you provide your Docker credentials, and then you can access the images which are behind the credentials. How to configure the dependencies for Docker image? Docker image should not have any dependencies. All the dependencies are inside the image itself for the application. What if I need update some configurations inside image? You can, when you run container from an image, you can add your own files or change the configurations while running a new image by either passing the options via command line when you do a Docker run, or by adding some file to the container, or you can create your own image as well based on the existing image with your configurations. Okay, both are possible. In the next coming sessions, we can talk about that. Will there be performance overhead when an app is run in Docker? No, there is no performance overhead. Can we run 2 Docker images on a single machine? Yes, you can run as many as the hardware allows. What is the best approach to create Docker image? We haven't talked about creating, so I can't talk on it much. There may be multiple containers on a single Docker station which have common dependencies, such as web server like Apache. How do we manage such sort of deployments? If there is a dependency, the dependency is within the container. So if you are running 10 different containers, each will have their own copy of HTTP server inside the container. Okay, so there is no conflict. Difference between Docker and Kubernetes. Kubernetes is an orchestrator which allows you to manage Docker containers across multiple systems. So Kubernetes is on top of Docker. What is Jenkins? Maybe some other session we can talk about that. Any good source of learning on understanding Docker in detail? Docker's own documentation is extremely good, and YouTube is full of Docker training sessions. So just pick any and watch. How to check CPU and RAM used by Docker? That's the Linux question. You can always use top command or ps command to see the RAM usage. Is Docker open source? Yes, Docker is open source. They have added some sort of licensing, but for individual users for testing and all, it's all free. Can we use Jenkins image on some machine where Docker is running? On the same machine where Docker is running? Of course, the image is used on Docker. All right, so there are so many questions. I don't think I will be able to answer all of them. Yeah. So yeah, maybe I will do another session where we can talk a lot about many questions that you have. I think if if we would have got more time on our hands, I could have covered a lot of topics. So it's easily 4 to 5 hours discussion to just touch upon and have some clarity on Docker without going into advanced topics. But yeah, that's the limitations. That's the time that we have. So I'm going to wrap it up now, right? Thank you for your questions. You will get the recording of the session. I think SkillUpRight is going to provide that. And I see a lot of advanced questions coming up as well, like Docker network and networking and container communication, Docker builds. So all these questions could be answered, but then it needs a lot of time. So I'm going to, right now, I will have to bail out on them. But in the upcoming sessions, definitely we can talk about it. Okay. So thank you for your time. And thank you for being with me, bearing me for an hour. And I'm going to see you in the next one. I have webinar every month on different topics with SkillUpRight. So yeah, I'll see you in the next one. Thank you and take care. Bye-bye.